So let's have a look at our arithmetic. So the sum to n, add up all the terms. So first term, or the second term, is a plus the common difference. The next term, a plus 2 common difference, and we would keep going and keep going and keep going. The last term I'm just going to call L for last term. So the second last term then must be L minus the common difference, and then the third last L minus 2D, and so on. In fact, that's so good, I'm going to write it again, but backwards. Okay, and by writing it backwards, we create simultaneous equations, and you'll notice everything matches up. Look, a plus L, d minus d disappears. A plus L, 2d minus 2d disappears, and so on and so on and so on. So we get all of these a plus L's, a plus L's, a plus L's. Question is, of course, how many of these a plus L's? Well, it was the sum to n terms, so we must have had n lots of a plus L there. Thus getting our formula, n on 2 a plus L. And that's great if we know the last term. If we don't know the last term, well, I can simply substitute in the general term for the last term, which is a plus n minus 1d, and that's why in this formula it's n on 2a plus n minus 1d. I think the most common mistake there is people will put a plus n minus 1d because we're so used to that with the general formula. But with the sum to n terms, it's 2a plus n minus 1d. Okay. So our first problem, we know the first term is 3, the sixth term is going to be 96, so what would the series add up to? Okay, I know the last term, I know the first term, I know how many terms there are. It's just a straight substitution question. So subbing all that info in, and we get 297. Okay. The sum of the first 100 even numbers, and let me just pretend for a second that, gosh, what is the 100th even number? No, I can't work that out. I just have no idea what that last even number would be. So in this case, I know the first term. I know it goes up by 2, so I know the difference, and I know how many numbers there are. So I can use the n on 2a plus n minus 1d formula. Substitute in, bit of tidying up, and there is 10,100. The sum of the first 10 numbers in our pattern is going to be 100. But the sum of the first 5 numbers is 25. They want us to find the first term, common difference, and the formula for the general term. So let's write down what we know. Sum to 10 is 100. So that means 10 on 2, outside of 2a plus 9d is 100. Let's tidy that up a bit. I get 2a plus 9d is 20. So there's one piece of information. They told me the sum to 5 was 25. So 5 on 2, 2a plus 4d is 25. Tidying that one up, we get a plus 2d is 5. 2 equations, 2 pronumerals, must be possible to find. So solve them simultaneously. I'll multiply the second one there by 2. 5 common differences is 10. So our common difference is 2. Therefore, subbing back in, we get that the first term was 1. Now we can work out our general term, a plus n minus 1d. Subbing in a, subbing in d, and there's our pattern, 2n minus 1. Using the sigma notation. So this time, I've got a formula I can use. There's the general term. I'm going from 1 to 10. So I know the first term is minus 3 when I sub in 1. I know the last term is going to be 24. And I know the number of terms is 10. So I'll use the a plus L formula, and we can work out that sum. Certainly a lot quicker than working out each individual one and adding them together. Oh, the thing to watch out for with sigma notation though, don't just assume it's starting with n equals 1. Sometimes they might say go from n equals, I don't know, 3 to 7. In which case n is not 7, n would be, so here 5, why 5? Isn't 7 minus 3 4? Yes, but it's inclusive, right? So you've got to add one back in. So 7 minus 3 is 4, but it means there's 5 terms all up. Okay, So 6i, so that would be 3 people looking at you.